Okay, so the next two sections, actually the next three sections, are all related to polar, okay, which is a new format of, it's going to start with coordinate points, we'll get into equations, and then we finish out on rate of change. So the first bit is like going from rectangular to complex, and then we're going to compare from complex to polar. So the complex plane is just like your x and y axis, except your x-axis is the real part of your complex number, and the y-axis is the imaginary part of your complex number. So if you remember, complex means it has an I in it. So if I had something like 3 minus 5i, that's actually a coordinate point just disguised in an expression. If I wanted to plot that, I would make that 3, negative 5. So I would go to the right 3, I'd go down wherever negative 5 is. And it would be a coordinate point, okay? So these you can overlap with a regular coordinate point, and then again, we're going to get into something called polar. But the first is complex. When you're plotting complex, you're plotting it on an imaginary axis. You don't. You put it into coordinate point form. So this one says plot the complex number. So if I had 2 minus 3i in coordinate point form, that could be what? 2, negative 3. So I go to the right 2, I go to negative 3, and that is that coordinate point. So that's A. And then negative 3 plus 4i becomes what? Negative 3, 4, which would be like up here. Very easy. Yes. Good so far.
So it's just like the coordinate point?
For now. Yeah. Yep. Then we get into something called the polar coordinate plane. You guys, you need to focus, please. So this is like a circle on top of a coordinate plane. That's basically what's happening. If you look at all the lines, all the diagonals, these are your special angles. This is pi over 6, pi over 3, pi over 2. This would be pi over 4. There are usually, like we will graph on those, but you can also see the angles in between are over 12s. So this is a pi over 12. That's where you'll see these added in. For the most part, we will stick to our original, over 6s, over 4s, and over 3s. But just know, like, if you look up polar axis, sometimes it has those over 12 lines. Now, what's different between this and what we were doing before with our unit circle is that our unit circle would have stopped at a radius of 1. So it would have literally just been that blue circle. Polar goes on unending, creating all these new radii. So this second loop, notice it has a 2 next to it. That's a radius of 2. Third loop has a radius of 3. And fourth loop has a radius of 4. All right, so again, and this polar grid has a radius. It goes up to 5, but obviously they can keep going. All they do is just keep extending it, almost like a bullseye, okay? So the center point is still your origin. That's still your 0, 0. But when we plot these points, they're going to have two parts. Instead of an x, y, it's going to be an r theta. So the first number is the radius. That's how far out you go, like on what loop. And the second number is your angle, and that's where you would put that dot. So if I had said 2 and then pi over 6, we would go to the graph where, God bless you, where pi over 6 is, and we'd count to the second ring, and we plot a point. So that is that coordinate point. It is 2 pi over 6. So it's along the pi over 6 ray, and it is on the second ring because the radius is 2.
Is the max of rings we're going to have 5?
No. Yeah. If it said, 7, if it said 7 pi over 6, now we're going to 7 pi over 6, and we're going 1, 2, 3 out to that third ring, and that would be that coordinate point. Now, hopefully, that's not hard, right? We're good? Mm-hmm. Yeah. What gets a little weird is when they start to bring in negatives. So if they bring in a negative on an angle, remember we go the other direction, or we fold like a hamburger, they can also put a negative on a radius. And if they put a negative on a radius, it means instead of counting towards the angle that way, we go the other direction. So if I said negative 2 pi over 6, then I would go along the pi over 6 line is where my direction's going to go, but instead of going towards that pi over 6, I'm going away from it too. So it puts it into the other quadrant. You count away from that angle, okay? So a negative radius says go the other direction. Same distance, yeah, you would still go to that radius. You would just go on the other side. So because these have different names, they can ask you for multiple representations of the same angle or the same coordinate point. Like I can use 2 pi over 6 to describe this point, right? I could also go the other direction and I could say 2, 11 pi over 6, and that's the same, negative 11 pi over 6, and that's the same angle. I could also say negative 2, 7 pi over 6, because instead of going towards 7 pi over 6, I go away from it. Or I can say negative 2, negative 5 pi over 6. Negative 5 pi over 6 is this angle, and it's saying count away. So it'll ask you for multiple representations of the same angle, and that's the concept. You mostly would keep it between, they'll either say between negative 2 pi and positive 2 pi, or it will say between 0 and 2 pi. And you've got to make sure that your angles fall between there.
Wait, Ms. Kirschwasser, why does the negative 2 keep, like, what does the negative 2 do to
It goes the other direction. So instead of going on the ray that your angle's at, your special angle, you go on the opposite ray. So like if I said pi over 3, let's say I said negative 3 pi over 3. Instead of counting towards pi over 3, I go opposite it. So I'd come to here where 4 pi over 3 is. The opposite direction.
So I go like
What do you mean?
like if I wanted 5, like that where pi over 2 is, like
Yeah.
the exact point.
So that angle, so whatever radius you want, and pi over 2. So I could say 3 pi over 2. And it's here.
Okay.
So you're going towards. Or I could say negative 3 pi over 2.
So if I say 5,
And it's the same point.
say pi over 2 is going to be like that.
5 pi over 2 would be 2.5 pi. Yeah, so at the top. Usually you'll look at the restriction though, because it will usually say something like it has to be smaller than 2 pi, so you wouldn't be able to use. But that is the same angle. They're coterminal. Yeah.
What would the negative 3 pi?
It's the same point. Because 3 pi over 2 is here, but instead of counting towards it, we count away from it. So it's still the same point.
Oh, okay.
Does that make sense? Yeah.
Is there like a correlation with the theta for all the 4 points?
What do you mean?
Like, you know how you could say the 2 positive radius versions, and there's like the positive and the negative of the theta. Is there a correlation between the theta points at all? Like, is there like a, I don't know, like a shortcut for it?
Not really.
Really memorized?
I mean, based on your original 4. Yeah.
So you always want to look at the angle first and then the
Yeah, like it gives it to you radius and then theta, but I go theta then radius.
That's easy.
Yep. All right. So let's plot these. I'm so excited that you're excited about polar coordinates.
I feel like this feels like a little easier than the last 4.
Good. All right, so 11 pi over 6 is which quadrant? 4th quadrant. Radius of 3 means I'm going right here. That would be number 1. Two, negative 311 pi over 6. So same angle, but what happens? Go the other direction. So I'm over here. That's 2. Because I'm going 11 pi over 6, which would be here, but instead of counting towards it, I go the opposite direction. Not 2, 3, negative 3. That's numbered 2, like as in example 2.
You go to like the original angle that's
And then,
given, and then you go the opposite direction.
like 11 pi over 6 is here, right? I want to go in the opposite direction. So instead of going towards 11 pi over 6, I go away from 11 pi over 6, which would be 5 pi over 6. That's when it's negative radius. Yep. Correct. Yeah. All right, 3 says 2 and 2 pi over 3. Where's 2 pi over 3? Second quadrant, and I go to the second ring. So that's 3. That was this one. And then 4, 3 pi over 2. Where's 3 pi over 2? At the bottom, right? So then I go to the 4th ring. and that's 4.
This corresponds to
Wait,
this.
so even that way is positive too? Like the left, like 1, 2, like the radius is in positive that way too?
If the radius is positive, you're counting towards the angle you're given.
Yeah, but like, so like this is also, like this wouldn't be
If
negative.
that would be, so this point, let's say this point here, would be, what did I just put that on the 4th ring? Yeah, that would be 4 pi.
So it wouldn't say -4.
It could say -4, 0.
Yeah, but like.
But if it's pi, it's 4. Yep. It could say 4 negative pi. All of those are the same. Yep.
For the last point that was just draw, what like quadrant would you count this?
You would say it's on the axis.
Okay.
Yep. So good question. If it said what quadrant are they located in, 3 pi over 2 is on the y-axis, not in a quadrant. Bella.
Why did, when we went to -3, why did we go to 11
This one or this one? Number 2?
Number 2.
So we started at 11 pi over 6, but instead of going towards it, we counted away from it. So because it's negative. So 11 pi over 6 is here. If it was positive 3, 11 pi over 6, my point would be here. But because it's negative 3, instead of counting from the pole towards 11 pi over 6, I count towards the angle opposite it. 1, 2, 3. Does that make sense? Yeah? Okay. All right, now how do we go from one form to the other? So you can get asked to go from polar to complex. You can ask to go from complex to rectangular, or complex or rectangular to polar. They all kind of mean the same thing though. If you're in coordinate point form, then you're gonna have, well, let me do the other way first. If you're in polar and you're going the other direction, it goes back to when we multiplied the radius by the cosine and the sine. If you remember this from like we did trig form. So you do r times the cosine of theta and r times the sine of theta. If it wants it in rectangular form, you would literally just leave it as r cosine theta, r sine theta, and then you would figure out what those coordinate points are. So it might be something like √3, negative √3. Like it might look like that. If it's in imaginary form or it's in complex form, then you put an I in front of the sign and you put comma instead of the parentheses. That's the only difference. So complex is still exactly the same, r cosine theta, and then r, there should be an I, didn't mean to erase the r. R sine theta, but I add the I in. That's the only difference between rectangular and complex. Complex has an I, rectangular does not. Okay, that's the only difference.
Is rectangular the normal?
Correct. Rectangular is like your regular points. Then if I'm going the other direction, if I'm going from complex or rectangular into polar, then you're going to get given a coordinate point, and it might be something like this, or it might be something like √3, √3 plus I √3. So this one is complex, and that's rectangular, but they're basically the same thing. Let me keep my signs the same. You'll get given a coordinate point or a complex number, and it wants you to get the r and the theta. So we get the r by doing the Pythagorean theorem, the square root of x squared plus y squared. If you think about it, you are basically making a right triangle inside your circle. That's all it is. So r is the square root of x squared plus y squared, or a squared plus b squared if it's complex. And then to find theta, we do the inverse tangent function. So we do tan -1 of y over x. Now what's different is that this is not the actual inverse, so we don't have to restrict it the same way that we did. You'll use your whole unit circle, but there's still only one right answer, and that one right answer is based on the location of the original point. So let's just say I had 1, -1 as my coordinate point. It's hard to see, but okay. Ignore the radius part of it and just go to the theta. I would say tan -1 of y over x, and I'd get tan -1 of -1. And there are two places on my unit circle in which tangent's -1. What are they? Quadrant 2 and quadrant 4, which would be 3 pi over 4 and 7 pi over 4. Only one of these is right, and it's based on the original location of this point. Where is 1, -1? Quadrant 4. So we keep 7 pi over 4. So there will be almost to every single one of those 2 answers, like with the exception, no, there's always 2 answers. And you have to figure out which one it is based on the location of your original point.
How do you know the location of your
Like plot it. So your point's gonna either both be positive, x and y are positive, first quadrant. Negative x, positive y, second quadrant. Both negative, third quadrant, positive x, negative y, fourth quadrant.
So you find the angle from the point you're given, and then you choose from the angle that relates back to your point.
Yep. And I would say it's the mistake people make the most. They forget to pick between the 2. So I would recommend you start by plotting that point. Start by figuring out where that is, then do the rest of the stuff, okay? Which go through. So this one is from polar to rectangular. So I'm going to do r cosine theta, comma, r sine theta. Notice it says rectangular and not complex. If it was complex, I put the I on it. So what is the radius? 2 cosine pi, comma, 2 sine pi. Where is pi? What's the coordinate point there? -1, 0. So what's the cosine? -1. What's the sine? 0. So what's this coordinate point? -2, 0. If it asked for it in complex form, it'd be -2. That's it, because there'd be 0 I.
Wait, if it asks for it in what form again?
In imaginary, what did I say? In complex, not polar. In complex or imaginary?
It'll take the sign of whatever the.
Yep,
You don't put a comma, because that's not a good.
correct.
Okay.
Wait, and which one do you not put?
You can actually put it, sometimes they'll keep the comma. They'll do it like -2. No, they don't put a comma. It'd be +0 I, but then it would, yeah. When they'll like, you'll see there's questions that are written out like in this part of your process, and that they might still have the I in, like that. You'll see like on your multiple choice, that might be something that you see. Yeah,
Is it always I?
for complex. Yeah, because the B is your vertical and the B is your sine.
So like if we did get another percent, we put I after.
Correct. We'll do one here. Yep. Because it's sine of pi. This should be pi. Yeah. Okay, so now we're doing √3 and pi over 6. Again, it's going rectangular. So it's r, which is √3 times the cosine at pi over 6. And r, which is √3 times the sine at pi over 6. What's the coordinate point at pi over 6? √3/2 and 1/2. The cosine would be √3/2. And the sine? 1/2. What is √3 times √3? 3. So this stays 3/2, and this stays √3/2. If it was complex, it would be 3/2 plus I √3/2. That's the only difference, is that it puts it into an expression, and the second one gets the I. Daniela.
How'd you get the radius?
It gave it to you. This is R. So if it starts in polar, the first number is your radius. Yep.
If it's if you get, would you ever get negative for sine?
Yeah, sure. And the second, the third, and fourth quadrants would be negative.
So if it's negative, you would subtract it.
Yep. So if that was like 7 pi over 6, it'd be a -1/2, and so it'd be 3/2 minus I √3/2. Yep.
Does it matter if the I is in the front or?
No. I don't know if you heard her. Does it matter if the I is in the front or at the end? No, just don't put it under the root.
How do you know, like, based off of the wording, which to choose? Like, for...
It'll say complex. Complex means I. Rectangular is just your regular coordinates. So complex means I. Polar means r theta.
Okay.
Is that what you mean?
Yeah.
Yeah. So you have to know, I mean, and this is where it's tricky, because for the most part, polar should be obvious because this is going to be a unit circle angle, but technically 0 is a unit circle angle, and you wouldn't know which one it is. It will tell you, take this from this form and put it into this form.
Always.
Yeah, like this says, put it into rectangular.
From what form?
Well, it might not necessarily tell you if it's not obvious that that's polar.
Oh,
Does that make sense?
yeah.
If it was a 0, you wouldn't know, and it would tell you.
Okay.
All right, so A, convert to polar coordinates. All right, so this is in rectangular. Before I even get started, I'm going to figure out what quadrant that's in so that I don't forget that that's going to be an issue later. So where would 2, 2 be? Quadrant 1. Then I'm going to find r by doing the square root of 2 squared plus 2 squared. Square root of 4 plus 4. Square root of 8, which is 2 root 2. Then I'm going to find theta. Tan of theta equals y over x. So tan of theta equals 1. Tan negative 1 of 1 happens what 2 angles? Pi over 4 and 5 pi over 4. So don't think inverse. You're thinking inverse. You got it. Yeah. And this is first quadrant, which means pi over 4. And then we write it as r, 2 square root 2, comma, theta.
Did you limit it to the first quadrant because, like, at the beginning we established?
Yep.
What if we didn't establish that? Like, would we go like based off the tan restrictions?
Nope. You have to base it off the original location.
Wait,
Yep.
When would you go with like the tan restrictions?
Not in anything, because we're using the inverse to find it, but really this is not the inverse. Like we are using arc cosine and tan negative, or arc tan and or tan negative 1 to find this answer, but it is really not an inverse. That's when it was just the inverse to begin with. That's when we needed to restrict it.
Oh, okay.
Does that make sense?
Yeah.
Like if the question said tan negative 1 of something, that's when we restrict it. But we're bringing in the tan negative 1, so you don't have to restrict it. All right, so going again, we're going this one's rectangular to polar. Where is negative 1, 0? X-axis, right? What angle's there? Pi. Do tan negative 1 of 0 over negative 1. What do you get? Tan negative 1 of 0. Tan is 0 2 places, which is 0 and pi. You already found it, right? Like there are going to be times when it is that easy. If it's on one of your axes, the 0, pi over 2, pi, 3 pi over 2, you don't even have to do that step. You could plot it and find it. So theta is pi. Now I just need my radius, but again, think about it. If I'm going to the left one, what's my radius going to be? 1. So my polar point is 1 comma pi. Yep.
Would you ever get a negative radius?
Not when you're doing it this way. Like they can give you the negative radius and you have to plot the negative radius. When you're finding it, this might happen and it might say find this one and then find another representation of the point. That's where you could have to pull that back in. But just finding it, no,
Okay.
because you're squaring. All right, last one says convert negative 3 minus 3i to polar. So now it's starting rectangular and we want to, starting complex and we want to go to polar. What is that coordinate point? Negative 3, negative 3. If the I throws you, take it out. So now my R, where is negative 3, negative 3? Quadrant 3. So I get the square root of negative 3 squared plus negative 3 squared. Square root of 9 plus 9, square root 18, which is 3 root 2. And then tan of theta equals negative 3 over negative 3. Tan of theta is 1. So we find the inverse. And tangent's 1, where?
Pi over 4.
Good. Pi over 4, 5 pi over 4. We already said it has to be in that third quadrant. So we're going to say theta is 5 pi over 4. Bless you. Questions? That's it. So the first part of your assignment's actually on WebAssign, and then the second part's on the AP Classroom. I didn't think this one was awful, so.